if a polynomial is of degree greater than 1 and a is any real number, then if then x minus a is a factor if pa is 0. That means if I put, like, if I have to factorize this, if I where's that thing? Yeah, if I factorize this by splitting the middle term, this will be y square minus 5y plus 6, and I will just split this. So this will become y square minus 2y minus 3y, because 2 into minus 3 minus 2 into minus is 6. Then I will take out y common. This will y minus 2 and then minus 3y minus 2. And this is y minus 2 into y minus 3. So these are the two factors. That means I can write this as y minus 2 into y minus 3. Now notice something. If I put y is equal to 2 here, what will happen? This will become 0. So this will also become 0. That means if I put 2 here or here, it will become 0. So if any number a is a 0, then y minus a is a factor. This is called the factor theorem. Again, I will repeat. If a is a 0 of a polynomial, then y minus a is a factor of the polynomial. That's what he's saying here. He's saying that in the factor theorem, he's saying that if pa is 0, that means if I put a, plug in a, and I get 0, that means 0 is a factor. Then x minus a is a 0 is a is a 0. So so x minus a is a factor. Is a factor. So this is another way to find these are the two factors. So whenever we know zero, now we actually know the factors. In fact, supposing he says this is if we know one factor of this, then we can just divide. We know when we divide this, there will be no remainder, and you can keep on. Uh, uh, factorizing it. If I'll explain what I mean. Uh, so he says examine whether x plus 2 is a factor. So if x plus 2 is a factor, then x plus 2 is x is equal to minus 2 is a 0. I told you now, if a is a factor, if a is a factor, a is a 0, then x minus a is a factor. So if x plus 2 is a factor, then mean minus 2 is a 0. So he plugs in minus 2 here. In place of x, he writes minus 2 cube, 3 minus 2. And what does he solve? He solves it, he gets 0. So by factor theorem, x plus 2 is a factor. So so we know the factor now. And we can divide. If I divide this, there won't be a remainder. So how do we, how to divide a polynomial by another polynomial? So let me divide. I will show you how to divide. So if this is a factor, then it must divide this. So let me divide this. So how do we divide this? So we say x cube plus 3x square plus 5x plus 6. How to divide this? Divide, if this is a factor, there should be no remainder. So I want to eliminate x cube. So I'll have to multiply this by x square. So it will become x cube plus 2x square. So I'll write x cube here plus 2x square. Then I will subtract like we do in division. This will go away. They will become x square. Then I'll bring the next one 5x. I have to eliminate x square. I multiply by x. X into x plus 2 is x square plus 2x. Again I subtract. I cancels out. I get 3x plus 6. I multiply with 3. So it will become 3x plus 6 and no 0 remainder. So this is a factor. So you can write this as x plus 2 into x square plus x plus 3. Because so this is these are the two factors of this. So this is how we using zeros. Actually, the concept is find a zero, and then x, let it be a, then x minus 2 a is a factor. Like here the 0 was minus 2 and x plus 2 is a factor. And then you can, if it's a factor, you can divide and you'll get zero remainder. And division is done like this.